Hi, and welcome to this new quickie. In this quickie, you will learn the true expressive power of the big O notation and its use in comparing algorithms and why we need it to compare algorithms. So, without further ado, let's get started. So, here is our desktop. Let's use the whiteboard. So imagine you were walking on the street and you've met your friend and he needs your help. He needs your help in finding his ID card in between 10,000 other ID cards. Your time is very valuable. You're a busy man. So he's your friend also, so you offered him 10 seconds to do that. From your experience, you've known that it's not the wisest choice to go for random search. Just searching randomly will likely lead to chaos. You will not even know the expected time needed because you only have this 10 seconds to search. So from your past, you remember that you used two methods. Let's call them method A and method B. They are just two ways or two algorithms that you used to search items. So for method A, you needed 10 seconds to find your item between 10 items, and for method B, you needed only 1 second to search between 10 sizes of shoes for your right shoe size. So same number of items, B is clearly faster. So you assume that it's also exactly 10 times faster. Here it takes 10 seconds, here it takes 1 second. So you assumed, hey, it's 10 times faster. But for your 10 seconds, you wanted to know how exactly time it will, method B will take you. You choose that, it's faster. Okay, so how much time it will take me? It's enough? Is it enough or what? So let's start with method A. You found that it takes you for 10,000 ID cards, 10,000 items, it took you same amount of time, which is 10,000 seconds. But for method B, you assumed that for 10,000 items, it will take you tenth of the time because it's 10 times faster of method A, so it will take you only 1,000 seconds. Surely it's faster than method A, but wait a second, it's not enough, you only have 10 seconds. So would you lose your friend? Actually, you would not. Why? Because your comparing wasn't that accurate. Your way of comparing is only good for comparing is this algorithm faster or slower in general, but not exactly how faster or how much faster. So what you've done wrong? Actually, what you've done wrong is the things that you use for comparing. So listen carefully. Just using the time needed for specific number of items, even if they are the same in the two methods, is not enough. What you actually need is the behavior and the growth rate of these two algorithms to compare them accurately and to know exactly the time needed. So you need to know how exactly time increases whenever you increase number of items or your list size. So for method A, it's easy, it's linear behavior. So for n items, you will need n seconds, easy. 10 items, 10 seconds. For method B, let me tell you that it actually behaves in a logarithmic behavior. So for n items, you will need log base 2 of n. So in our example, for 10,000 items, you will only need, surprisingly, only 4 seconds. And now you don't only have the time to search, you only have extra 6 seconds to have a friendly chat with your friend. Not only that, you will likely have more than 6 seconds to chat with your friends, because what we have actually just calculated is the worst case scenario. So at max you will need 4 seconds. At the very worst case, you will likely need 4 or less seconds to find your friend's ID card. And actually what we have used is a very known mathematical notation called the big O notation. It's used to describe the worst case scenario or the worst case complexity of an algorithms, and it's very useful and used very much when comparing to algorithms. So you don't use this previous wrong method that you used. You will mostly use this big O notation. It's very useful. It's not the only notation. We have also the theta notation, for example, that finds the average. We sometimes need it, but here's the big O notation. So you have helped your friend and you're happy. But to make it a complete quickie, let's get a small math insight to link things together, math and programming and algorithms. So what you were doing wrong is you was just getting one bit of information or 1 point on the graph. For a specific number of items you need a specific number of seconds. Here is also 1 point. As you see, 1 point is not enough to describe a behavior. It's not a holistic description. So it's not very powerful in expressive power, let's say. So what we have found later to find the accurate time and a better comparison is the whole behavior using the big O notation, which is the whole curve, the whole behavior of the two algorithms. This is linear behavior, this is logarithmic behavior. That's it for this quickie. I hope you learned and had some fun. See you in the upcoming quickies. Thank you.